We started inverse trigonometric function in our previous video. Now we will discuss the inverse, we will talk about inverse tangent function, and this is lecture number 81. This is also very interesting function in inverse trigonometric functions. So first of all, we want to see either this function satisfies the property of one-to-one functions or it satisfies the horizontal line test. I already plotted this function over here, and you can see that this is a very weird function since you know that the tangent function is written as sine x over cos x, and it has discontinuities when we have cos of x is equal to 0. So x is equal to pi by 2 minus pi by 2 and so on. These are the discontinuous point where we cannot draw tangent x, and these are the vertical asymptotes as well. So you can see that this is the vertical line which tangent x cannot cross. So we have one branch over here, and that branch actually travels along minus pi by 2, but it never touches minus pi by 2. And same is the case with pi by 2 as well. For your understanding, I also plotted the same tangent x in interval minus pi by 2 to minus 3 by pi by 2. So here again we have tangent x that actually just move along minus pi by 2. It moves parallel to minus pi by 2, then it reaches at 0, and then we have minus 3 pi by 2 where it just moves along this value, this vertical asymptote. So this pattern actually continues like this. So we have something like this. But when I look at the horizontal line test, you can see that it just passes through with 2 points. So we cannot find a tangent inverse x on this domain. Remember that the domain is, in this case, for tangent x is y is, x is minus pi by 2. Uh, we want to see we want to restrict the domain as well. So here the domain is minus infinity to infinity and so on. Okay. So first of all, in order to find the inverse tangent function, we have y is equal to tangent x, and we want to restrict the domain so that we get one-to-one function and we get inverse function. So I raise this branch and all the other branches as well. So what I get a function which is one-to-one. So y is equal to tangent x over here, and the tangent x has a domain in the open interval minus pi by 2 to pi by 2. It should not be a closed interval. The reason is minus pi by 2 and pi by 2, the endpoints are the discontinuous points over here. So the step 1 is to write the y is equal to tangent x and restrict the domain. The second step to find the inverse is replace x with y and y with x. So this is y is equal to x and x is equal to y. That's how we do it. In that case, the domain becomes range and range becomes domain. So y is equal to, y is minus pi by 2 to pi by 2. Since in tangent x we had a domain from minus pi by 2 to pi by 2, so now this becomes a domain for the inverse function. And we can simply write this as y is equal to tangent inverse x. So this is the uh, tangent inverse x. Okay, now I just want to see how tangent inverse x look like. For tangent inverse x, the domain is minus infinity to infinity, and the range is y minus pi by 2 to pi by 2. Okay, so suppose we have uh, we want to draw this function. Let me see. On the y-axis, we have 1 over here. For example, this is 1, and this is minus 1. Then we have pi by 2, and then we have, suppose this is minus pi by 2. I'm sorry, this is plus pi by 2, this is minus pi by 2. On the negative y-axis, we have negative values. Okay. Now, the domain is minus infinity to infinity. It means that it can take any value on the x-axis. But on y-axis, it cannot cross pi by 2 and minus pi by 2. It cannot cross that function. The original function was restricted on x-axis by minus pi by 2 to pi by 2, and y-axis was minus infinity to infinity. The actual function, in fact, which was 1 to 1. So now the domain is minus infinity to infinity. So we have, let me just draw that again. This is minus pi by 2 and this is pi by 2. The minus pi by 2, since it cannot, the inverse function cannot cross this horizontal line, and the inverse function cannot cross this horizontal line as well. So the actual function will look like this. It will look like this. I just draw this a rough graph over here, something like that. Okay, only one branch should come over here, and this is actual one. So this is our y is equal to tangent inverse x, and if you want to see the reflection, then you will see the reflection something like this. This is the this is the line where we have the inverses reflected with each other. So that's how we define. Let me just redraw that function for you. Tangent inverse x is a difficult function to draw. So this is x-axis, y-axis, and we already decided that the range will be minus pi by 2 to pi by 2. The inverse function, sorry, the inverse function will look like this. So this is our inverse function, y is equal to tangent inverse x. So you can easily find the values for tangent inverse x. Thank you for watching.